Alrighty, welcome back to another state test prep video. Today we're doing standard 7.G.2, the second of our geometry standards. Let's hop right in. Question number one from the Ohio Practice OST. A quadrilateral has the given attributes exactly one pair of parallel sides and exactly two right angles. Create a quadrilateral with the given attributes. So let's talk about what these things mean. Quadrilateral has a four-sided shape. Okay. You think a quad, four sides. Okay. It has exactly one pair of parallel sides. Exactly one pair of parallel sides. That means that you have two sides that will never touch each other no matter how far they go on. Okay, if you extended the lines out forever and ever and ever, they would never ever touch each other. However, it says exactly one pair of parallel sides. Exactly two right angles. A right angle, being a 90-degree angle, will look like this. Okay, so what does this disqualify? This disqualifies a square. Why does it disqualify a square? Because it has two pairs of parallel sides, this one and this one. And it also has four right angles. It disqualifies a rectangle because it has four right angles and two pairs of parallel sides. It disqualifies what some would consider a standard trapezoid. When people think trapezoid, usually you think of something like this. This has exactly one pair of parallel sides, the top and the bottom, the two bases. These sides, if you extended them, would end up crossing. However, the problem is it doesn't have the right angles. There are no right angles here. So what can you do? Well, we can make it be a right angle. What if we were to, I don't know, cross this part out right here, and we were to just draw a straight line down? What if we were to essentially cut some of this trapezoid out? Now we have two right angles. Now we have exactly one pair of parallel sides. And if you cross all this out, now we have a quadrilateral. There are 1, 2, 3, 4 sides. So this is what you need to do. So we're going to draw a straight line down here. And then draw another right like this. Another route up. And over. This has your right angles. This has your one pair of parallel sides. You're good. Question D. A triangle has a side length of 3/4 of an inch and a side length of 3 inches. What could be the length in inches of the third side of the triangle? This is something you might have learned called the triangle inequality. Ooh, that's not how you spell inequality, Mr. Dietz. Theorem. Which is a fancy way to say that if you know two sides of a triangle, you can roughly guesstimate what the third side would be. How this works is you take the difference of the two sides that you know, and the sum of the two sides that you know, and your angle has to be somewhere in between here. So let's refer to the difference of the two sides as D and the sum of the sides as S. So that would mean that your D would be less than x would be less than s. Whoops. Where x is the length of your third side. So realistically, what you can do, you would take 3, you would subtract 3/4 of an inch. Okay? That gives you 2 1/4. And you notice I'm kind of hand waving over this because there's a very simple trick to this. 3 3/4. Great? Great. Okay? So your answer can be anywhere between 2 1/4 and 3 3/4. Here's the trick to this question. The trick to this question is that you can always just pick the larger of the two sides. You can always just pick the larger of the two sides. Just pick 3. It's an isosceles triangle. You're good. You're done. Just pick the larger of the two sides. Could you pick 2 2/4? Sure. Could you pick 3 1/4? Sure. Could you pick 3 1/3? Sure. 3 1/2? Sure. Well, why reinvent the wheel? You know you can just pick 3. Just pick 3. Question 3. Spring 2019 OST. A triangle has 2 equal side lengths and a third side that is shorter than the other 2 side lengths. Use the connect line tool to create a possible triangle. So the only rules you have to have for this is that A, it has to be a triangle, B, 2 sides have to be the same length, and C, the third side has to be shorter. All right, so let's talk about how you do this. Ready? What you want to do is you want to make a really steep line. Okay? We're going to pick a point in the middle. Bam. Right here. And we're going to keep track of how many spaces we go left and how many spaces we go down. You want to go down far more spaces than you go left. So we're going to go like this, like that. Perfect. So from here, I went 1, 2, 3, 4, 5, 6, 7, 8, 9 down, and 1 to the left. So now I'm going to mirror that, and I'm going to go 9 down and 1 to the right. And then just connect the 2 points. This has a length of somewhere like in like the 9.2s. This has a length, an equal length somewhere in the 9.2s. And this has a length of 2. That's all you need to do. Steep triangle, more spaces down than you go to the left or right. Make sure you mirror it exactly. If you go 2 spaces to the left of your starting point, then you need to go 2 spaces to the right of your starting point. It needs to mirror. Question 4. The length of the 2 sides of a triangle are 4 inches and 7 inches. What is the possible length in inches of the third side? So again, we can talk about the triangle inequality theorem again, where you could subtract the 2. 7 minus 4 is 3. Or 7 plus 4 is 11. And your side just has to fall somewhere between 3 and 11. Or, and hear me out on this, you could just pick the bigger of the 2, which is 7, and just say 7, and say it's an isosceles triangle, and be done. Easy. Question 5. Vanessa states that parallelograms never have right angles. This is a 2-part question. Part A, select the box to show whether Vanessa's statement is correct. And part B, use the connect line tool to draw a figure that supports your supports your answer in part A. Let's talk about the rules to be a parallelogram. Okay, the rules to be a parallelogram are that your opposite sides have to be equal. Your opposite sides must be parallel. And your diagonals have to bisect each other. Your diagonals have to cross in the middle. I can never remember how to spell diagonals. These two are the main rules. Opposite sides have to be equal. Opposite sides have to be parallel. Does that mean that parallelograms can never have right angles? The answer is no. Because you know a parallelogram has right angles. You just don't know it as a parallelogram. You know it as a rectangle. A rectangle, while being a rectangle, does follow all the rules of the parallelogram. Opposite sides have to be equal. They are. Opposite sides have to be parallel. They are. Your diagonals must bisect. That's something harder for you to test, but I assure you, they are. Okay? This follows all the rules of parallelograms. All rectangles are parallelograms, but not all parallelograms are rectangles. So her statement is incorrect. Excuse me, because you can just draw a rectangle. Question 6. Last one for this video. Select the boxes to identify whether each shape is a parallelogram or not a parallelogram. Again, follow our two rules. Opposite sides equal. Opposite sides parallel. Does this follow the rule? Yes. Parallelogram. Does this follow the rule? No, these are not parallel. Does this follow the rule? No, these two lines are not parallel. Does this follow the rule? Opposite sides equal, opposite sides parallel. Follows the rule. Does this follow the rule? Opposite sides equal, opposite sides parallel. Follows the rule. That's it. So that is standard 7.G.2. If you need any assistance, please let me know. But thank you.